and Katika Sangwan. Steve is a teaching fellow at Imperial College London, specialising in planetary surface processes, I think.
Yeah.
And Kartik is a PhD student studying surface processes on Mars. And Katika Sangwan. Steve is a teaching fellow at Imperial College London, specialising in planetary surface processes. And Kartik is a PhD. Stop! Thanks. You're allowed to sit down.
All right, thank you.
So thanks so much for joining us this evening, and welcome. For anyone joining us online who's been watching The Martian at home, hi, welcome to the Geological Society live Q&A about the movie The Martian. We've got a few questions that have come in through our socials already and online, but does anybody in the audience want to kick off the Q&A for us? If you've got a question and come to you, just wait till Ashley gives you a mic so that your question will be picked up on the recording as well. In the middle here. Go ahead.
Hi. So that film was enough to convince me going to Mars is a horrible idea. Looks terrible and terrifying. And I guess I'm interested in sort of why you think we should be studying Mars and why you think money should be being spent in that study. Like, I'm just very interested what you think the reason for it is, the benefit for it is, why money should be plowed into it. Because yeah, I'm now like, let's never go to Mars. It looks terrible.
My mic has died, so I'm going to shout.
Yeah, 3 reasons. The first reason's technology. So from investment in sort of, like the machinery and equipment to go and explore distant planets, you can sort of get lots of sort of technological advantages. So I think with the Apollo program, they worked out that for every $1 they invested in the program, they got a science return of $17. And this wasn't just like little things like like supposedly inventing Velcro and things like that. It was sort of the evolution in computing that they got from building the Apollo guidance computers and things like that. So it's all of those things that you'll get. So just by investing in going to Mars, you would get, I don't know, like a millionfold improvement in technology of all the things we can't see. The second one is sort of a science reason. So going to Mars, we can look at the surface of Mars and understand what Earth was like about 3 to 4 billion years ago, back when sort of life was probably taking hold on Earth. And most of the rocks on Earth where life was taking hold have been destroyed. They've been sort of gone through the plate tectonic mill and have been reworked. So there's very few rocks. And the ones that are left are sort of metamorphosed beyond hope of seeing any evidence of life. So we can go to Mars and see what planets look like sort of in their early evolution. And then the third one as well is more of a philosophical reason, is just that drive to explore. And like, it's probably better to go to Mars than do other expensive, pointless things. Like it's just that human need for exploration, I guess. Like the whole reason why people sort of left their local area, built a boat, sailed to the New World, sailed to Australia, designed spacecraft and went to the moon in the first place. So I guess Mars is the next easy step.
I mean, if I can add one point, I mean, it's a cool place. I mean, it's not, yeah, it's unlivable, but it's cool. And yeah, Steve said, it's probably a stepping stone to what's next, right? If you want to go to outer solar system, you want to go to other places, you have to start somewhere, right? So what's closest to us? Well, technically it's not the closest to us, but at least some place that is very interesting to explore. So yeah, it's cool.
Anything you'd like to respond, or is that a good answer? Okay, let's take a question from online. We've been asked, there's a few questions. What about, is the landscape depicted in the film a realistic portrayal of what Mars looks like?
Some of it.
Quite close. So if I'm not wrong, the movie was shot in Jordan.
Yeah.
And it depends. So if you if you go right in the middle of a crater, it might be something else. If I'm not wrong, this is more closer to, if you look at the map of Mars, it's quite strange in the sense it's got this strange dichotomy where there is highlands in the south and it's completely flat land in the north. So if you land in that area, you would see something else. So it's kind of like, to answer this question, it'd be something like, if you were not living on Earth, you were living on some other planet and you had to explore Earth, where would you land? And it would depend, like all the places would be different and you would learn different things from different places, whether you landed in the middle of ocean, you landed in somewhere in China, you landed on this island or anywhere. I don't know if you have something to add to that.
Yeah. So a lot of the rocks in the film were layered rocks, and you would expect to find layered sedimentary rocks in many places on Mars. So in Gale Crater, we find layered rocks in the central peak, Mount Sharp, and again where many of the other rovers have traversed. And as Mark was driving around, we saw ripples on the surface. We'd expect to see those as well. But what we didn't see were the large ripples that are quite common on the surface of Mars. So on Earth, you have sort of the small ripples, which are sort of that size. Sorry, did I say Earth or Mars? On Earth, you have ripples that are this size, and then the next one up is sort of, you go into the dune scale features, which are sort of on the order of about maybe 5 or 10 meters high. On Mars, you have an extra large ripple in between. So you have the ripples that size, and then you have sort of large ripples, which have a wavelength of about that big. We didn't see those in the film, but that's an easy mistake to miss. And also as well, it's really difficult to make those on Earth unless you go somewhere really cold.
Cool, thanks. Any other brave people in the audience want to fire up a question? Yeah, Ashley's just bringing you the mic. Hopefully that one's still got battery.
Sorry, I was just interested to what causes those intermediate ripples on Mars there. What's the reason for that wavelength?
So it's because of the thin atmosphere. So Mars's atmospheric pressure is about 6 millibars compared to the 1,000 millibars average pressure we have on Earth. So because now try not to get too technical. The density, no, the dynamic viscosity between Earth and Mars is about the same, but the density of the air is much less. And because your density is much lower, you have a higher kinematic viscosity, which is the dynamic viscosity divided by the density of the air. And because you've got that higher kinematic viscosity, you have different saltation pathway jumps. So when the wind blows, it'll pick sand up and the sand will sort of bounce. On Earth, it bounces maybe that far. On Mars, it'll bounce like 1 meter or 6 meters or so. And it's because the grains jump in a slightly different way. Is that why you get these larger ripples form? Also, as well, there's less drag from the atmosphere because it's thinner. So it just allows these ripples to grow larger up into the boundary layer.
Can I just ask for the non-geologists in the room, can we have like a simplish explanation of the ripple marks we're talking about? Just
so basically the atmosphere's less dense and it's thinner. So it allows ripples to grow larger without flattening them out, I guess. So that's why you get the big ripples.
Cool. Thanks. Yeah, in the middle here. Oh, sorry, can you just wait a sec till you get a mic?
Thank you. I have two questions. The first one is, could you talk a little bit about the mineral and metallic contents of Mars? I mean, what is the value of it economically if supposedly we built a factory there, for instance? And then the follow-up question would be, if this is true, then is there like a chance to bring them back to Earth, or would they be only of use there if dug up and used in the factory?
I can take the second one. I'm not sure of how economical they would be to mine. I mean, it's not just with the mineral resources, it's not just the presence of minerals or that metallic content somewhere, right? It's also the cost associated with going there, extracting everything, and then bringing it back to Earth. I mean, for context, we have a rover right now at Jezero Crater, whose the whole mission is of a sample return, and the total time span of that is probably like 10 years or something, right? So it's, for your second part, I don't think it's going to be economical to get, at least in the short term, or at least even in the midterm. I don't know about if there are any particular cool minerals that we can get back from Mars.
Yeah, so
except for a lot of iron.
Yeah, so the average composition is sort of basaltic. So there is a lot of, a moderate amount of sort of things like iron and magnesium in basalts. It's not particularly well concentrated because there's no plate tectonics. So if you think of a lot of the plate tectonic processes where you have sort of associated fractional crystallization and reworking, which and then with subduction zones, you have a lot of hydrothermal and other sorts of processes which concentrate your minerals. There's not that going on the surface of Mars. So you've not really got any sorts of processes that concentrate minerals into an economic volume that you can work like we would think of. However, there are some mechanisms associated with cratering where you get hydrothermal sort of activity associated with it. Whether that would concentrate any useful minerals to a point where you'd want to go and exploit them, that's a different thing. In other places, so for example, on the Vera Rubin Ridge in Gale Crater, I think there's iron concentration up to about 10 or 14%, which was probably a diagenetic process. That'll be sort of water flowing through Gale Crater and depositing minerals. So I guess 14% concentration on Earth would be pretty good, but it still wouldn't be worth sort of lifting those materials. And also as well, it's only iron. Like you can go dig up iron out off Earth like so cheap compared to trying to blast like a ton of it off Mars. It would cost you like £1 trillion or something. Well, £1 billion at least anyway.
Only $1 billion.
Yeah.
Cool. Thanks. Let's take a question from socials. How long are days and nights on Mars?
I think the entire day is 24 hours and 39 minutes, so almost close to what we would have on Earth, plus some change seconds. I think it's about 35 if I'm not wrong. And your total year would be about 680, I think around 680 Earth days. So approximately double the time around the sun compared to Earth.
And in the movie, when they refer to sols, that's like the equivalent of a day, right?
Yeah, that's one solar day.
Any questions from the audience before I? Ooh, you pick, Ashley.
So if you got a chance to assemble your own crew of 6, and you can be completely selfish about this, who would you choose? Like, what kind of scientist would you choose to be on that crew? And would it include a botanist?
Would it include?
A botanist.
I know the one person would be Steve, and then Steve would be the person that I would leave on the planet to get back to Earth. But yeah, but other 5, that's a good question. I would select a botanist just in case somebody gets stuck. We can at least leave the botanist behind. They can grow some plants. But yeah, because I'm a geologist, I'd probably pick like 5 different kinds of geologists who would do like 5 different things. And yeah, that would be my crew, and we'll do geology and then get back to Earth if we can.
I probably would take a botanist as well. Since Andy Weir wrote the book, they discovered perchlorates in the soil. And perchlorates are basically not far away from being bleached. So it would actually be really difficult to grow things in the soil. unless you probably rinse the soil through with water first to try and remove these bleach products or bleach-like chemicals. And once you've done that, then it might work. So it'd be useful to have a botanist to see if you could grow something. I'd probably take a geochemist as well, who could also look for like biosignatures. So look for molecular evidence of life in any soil as well. I don't know what the other people would be, but one good opportunity, channeling my boss, he would probably take or send somebody like an artist or a poet to describe the landscape, because scientists are relatively bad at sort of describing things in a poetic manner. But if you sent an artist or a poet, then they could sort of describe the landscape for people.
Actually, that reminds me, I might take a materials engineer then to remove all the perchlorate out of the soil.
Yeah, could work.
That's a good idea.
Maybe any volunteer poets or artists in the room to go with these guys to Mars. Was there another question towards the back here? Yeah.
Thank you. I had two, but you answered one of them about how realistic it is to grow potatoes there. And the second one I had was about fixing this big hole in the station with the duct tape, and then withstanding some storms there and things like that. Do you think something like that, you know, is it not fatal what he experienced there? And can he actually fix this?
Yeah, go ahead.
Yeah, it probably would be possible to fix it. The pressure inside the habitation unit was it was reading as 12 psi. On Earth, atmospheric pressure is about 14 psi. So I guess they're running it a little bit less. The outside air pressure would be, from Googling it 30 minutes ago, would be about 0.08 psi on the outside. So I guess it's less than the pressure in your bike tires. So you probably would be able to do something like that. So you probably would be able to fix it. But also as well, they would send a repair kit just in case something did go wrong, because there would be no way of helping otherwise.
Yeah, I mean, for context, 12 psi would be something that you would find in hilly, for example, Denver, or areas around Denver would probably have 12 psi. So yeah, perfectly livable.
Duct tape works on Mars.
Yeah, it depends how long the exposure has been like. Yeah, duct tape would work.
Thanks. Any more audience questions? Let's go to the back here. Sorry, Ashley, making you run around all over the place.
Yeah,
Hello.
while you go there, I think one point that you did say was about something about the storm, right? Yeah, Martian atmosphere is really thin, so I think that's one of the, I guess, inaccuracy of the movie early on.
Yeah.
You wouldn't get such large, even in that case, it would just feel like a gentle breeze, so it wouldn't be like that.
Yeah, if that. It's a wonderful plot device, though, to sort of make the progress the film by having this storm, but it would never happen. I don't even think you could have wind strong enough to lift sort of gravel that size on Earth.
Thanks. So you mentioned perchlorates in the soil. What do you see as the other main obstacles or barriers to human habitation of Mars?
Probably the dust, maybe the dust. So with the Apollo missions, they found that the dust would get into all the joints on the spacesuit. And I think it was it Apollo 17 they had some of the longest extravehicular activities, and they found that by the last mission, they were really struggling to sort of make the connections in the suit. And all the wrist joints and the shoulder joints were just that full of dust that like they were sort of grinding and creaking, and that would eventually sort of cause leaks within the suit. Also as well, it'd be nasty to breathe it in as well. So as well, if it's got that perchlorate in it and you're breathing in like really fine dust particles all the time, and there's bleach in there, that probably won't do you good. And no matter what you did, everything would be covered in dust all the time. So you would sort of go outside, come back in, and all your spacesuit would be covered in dust. So it'd be everywhere in everything, damaging anything and everything.
Uh,
beginning of Interstellar.
Ooh, can't remember that.
There was a lot of dust on the Earth until they.
On the other factor would also be, I think, gravity, because we really downplay what gravity does to human body. So I mean, it is quite common, like when we have space shuttles returning, the astronauts sometimes have lost so much muscle mass that they are literally pulled out of it instead of themselves climbing out of it. So that would be another hurdle, assuming that you get oxygen and water sorted out, because until very recently, we didn't produce oxygen on Mars. So very recently, with the NASA's Perseverance rover, they have this device known as MOXIE. It's an instrument, and they use electrolysis essentially to break down and get oxygen, because it's in trace amounts in Martian atmosphere to get oxygen from carbon dioxide. So if we have that sorted out, I think they produce about like 5 grams, which is quite less. You could probably survive for 10 minutes.
Thank you. Sorry, this is more of a geopolitical question than a geological one, so bear with me. We saw in the film the Chinese support the US on the mission. How much do you think international collaboration will be important for achieving, humans' goal of reaching Mars, and also more nefarious tactics? How damaging would they be?
So the reason why the Chinese helped out the Americans is because they got a free ride on the Ares craft. So there was a political motivation that they basically gave up a rocket, which is relatively cheap, for a seat on the spacecraft. So there probably would be dealings that happened like that. Also as well, different countries are particularly good at designing different instruments. So if I remember right, the Curiosity's SAM instrument, there's loads of French geochemists on that team contributing to it. And it's the same with ExoMars's MoMA instrument. Loads of French guys working on that, and with the ChemCam on MSL, there's just loads of French guys working on there. So France has made like a massive contribution to sort of geochemistry, and it's the same with other different countries. Like they have their own specialisms, so it probably would be sort of quite an international collaboration, at least, well, probably in some cases. But if they wanted and sort of reach deep in the pocket, America probably could pull it off on their own if they had the inclination to do it.
Okay. Any other questions before I go back to the social? We take, there's no such thing.
No such thing as stupid questions.
How realistic was the Xavier and ending, like, probability wise? Is it like 1 in?
I don't know, but it deviated from the book because the captain stayed in the spacecraft as they should. Like, the captain should never leave and do anything daft like that, because then if they're lost in space, then that would go out the window. Yeah, I probably wouldn't want to try it, but in a desperate situation, it might work, like one time in 100 or something.
Oh, that's higher than what I thought.
Yeah, I think there's one of the dialogues where they say, like, how many times do these tests and things that they do in order to cut time, they ask the question, like, how many times do these tests turn up a problem? And he says like 1 out of 20, right? Probably that would be the answer, I guess.
Yeah, there are published like results on like rocket reliability. Soyuz is really reliable, even though it's not changed since about 1957. Then there's other statistics as well. So I think, what was the rocket they launched Curiosity on? Sorry. But they have to take into account the failure rate when they put in things like RTGs, the lump of plutonium that powers things like Curiosity. Like, they prefer to use more reliable rockets in case it does explode. And then it doesn't shower nuclear material everywhere. But then those things are designed to withstand like a launch explosion as well.
Has there been, I know it's not been like necessarily manned interceptions like that, but have any other, is that a common thing in kind of space exploration that you have interception of craft like they did?
They did it in the 60s when they were practicing for the Apollo missions. They did some practice interceptions, and then there was it an Apollo something or another where they actually sort of one of the first interceptions where the Russians intercepted the Americans. It was I can't remember if it was, I want to say it was a friendship mission, but it wasn't. But basically they met up in space, and but it wasn't anything like that where they were leaping from one spacecraft to another.
Yeah, I don't think the intersection of like two different human beings per se would have happened.
No.
You know why everything is named after Greek gods and Greek mythology? All this craft and all the computer programs and everything.
I don't.
The only knowledge that I have about the names is like just the Mars is like, I think, the Roman god of war. And then my name is Karthik and I'm the Hindu god of war. So that explains why I'm studying Mars. So that's my only knowledge on the names.
Oh, that explains something.
Yeah.
Why the missions are named after Greek things, or?
Yeah, well, just because one of the computer programs in the film was called Pleiades. And they're all called Apollo or Mars, or I just wondered where that came from.
I guess it's just because the ancients named so many constellations and planetary bodies. So I guess it's just an extension of that. Like even when they discovered Pluto in like the 30s, they gave that a Greek name, and then they named the moon Charon as well. So I guess it's just sort of a continuation. And then as they've sort of progressed and ran out of Greek gods, then they start naming things after other religions' gods as well. So if you go to Titan, there's lots of like Hindu gods, features named after Hindu gods and other religions' gods as well.
At least like when they're exploring, they have, if I'm not wrong, they have this random name pull out, like depending on like different countries. So
yeah,
at least with the MSL, there are a lot of Scottish places named after a lot of Scottish places, a lot of localities in there. So that they are changing now, I guess.
Yeah, although those are unofficial names, they're not actually recognized by the IA, the International Astronomical Union. And they have like a big long list of criteria that you have to go through to get it named. Like it has to be a certain size and geographically or geologically significant as well. I think there's a whole website sort of explaining like all the naming convention if you want to read it.
But there will be a planet named after me one day.
Is it considered bad form to name a thing you discover after yourself?
Yeah, and after somebody who's alive as well. So. So there was a recent mountain named Rafael Navarro in Gale Crater, and that was named after a famous Mexican astroscientist. I can't remember what he did, but he was a Mexican guy who sort of helped out, or he was quite a strong researcher in the field, in the astronomical field, and he got a mountain named after him after he died. There was also a guy on the team who passed away just after a Viva, taking a Viva, and they named a dune after him, a guy called Nathan Bridges. And Octavia E. Butler, he was a author as well, and Bradbury Landing as well was a. They seem to name landing sites after authors.
Okay, got to write a book if you want a place named after it. So, should we go over here for this question?
How much fuel would the spacecraft like Chinese need to go to Mars and back?
That's a really good question.
I don't know. Lots. And then to get back, you would need to build a rocket big enough to get from the surface of Mars So you've got to build a rocket on Earth that can take this rocket to get from Mars. So the rocket basically grows exponentially per kilogram you want to lift off the surface of Mars. So this is one of the reasons why it's difficult to get things back from Mars, is just because you need a rocket to get from Mars, and then you need to fly that rocket to Mars. They're getting around some of the fuel problems with that MOXIE instrument that Kartik mentioned earlier. So if they can make oxygen on the surface of Mars, then they can potentially make fuel on the surface of Mars. And if you can do that, then that saves you an awful lot of weight launching from Earth, because most of the weight in a rocket's actually fuel and not a lot of its payload. So if you can make your fuel there, then you save a lot of weight on the way out.
Also, you save a lot of fuel. So if you, in the movie, they show this thing about the Rich Brunel move, which is basically a gravity assist. It's a lot more common in planetary physics than they show in the movie. So you would commonly have that if you're going to outer planets. You would generally fly by other planets and get a gravity assist. So that saves a lot of fuel as well.
We have a quick explanation of gravity assist for me, if not for anyone else.
Yeah. The best analog I've heard for a gravity assist is if you got a tennis ball and you throw it at a lorry as a lorry's driving by. And if you think when the ball hits the lorry and bounces off, it'll bounce away with a lot more energy. And it's basically the same with a gravity assist. So when a spacecraft sort of goes around the planet, you steal a little bit of the angular momentum of the planet to make the aircraft go faster, the spacecraft go faster. But because the planet's so massive, it's like a negligible amount of energy stolen from the orbit. So basically, you can get the spacecraft to go faster by stealing some of the planet's angular momentum, something along those lines.
Cool. Any more audience questions? Going back into the middle here.
If you had a much more powerful engine, would you still go to Mars, or would you go to any other planet in the solar system, and why?
Ooh, Mars is probably the easiest. Titan would be a really good shot. I wouldn't mind going there, just because it'll be a really easy planet to get around on. So because the atmosphere is about 1.5 atmospheres, it's really easy to fly there. So you could have a helicopter and sort of fly around the surface and have a look. The only problem is that it's about 98 Kelvin on the surface, so everything's frozen, including probably you after not long. But on the flip side, there's lots of fuel around, like there's lakes of sort of petroleum-like fluids, and it rains methane. So you wouldn't be short of fuel. You'd probably be short of air to burn it, to use it. Yeah, I wouldn't mind going there.
If I had to go, I mean, it depends on the kind of science question that I would be trying to address. I mean, that's classic PhD answer. Basically, so in a hypothetical, if you ask me, my favorite planet is probably Pluto. It's not a planet anymore, sorry. But yeah, it would probably be Pluto. We'd go to Pluto, but yeah, as I said, it would be more dependent on the science question that I'm trying to answer. So, for example, if I want to go to one of these icy satellites around Jupiter or Saturn, what kind are we looking for? Astrobiology there, or are we looking for mechanisms of tidal heating, for example? With Mars, the questions are easier to answer because as geologists, it's easier to associate problems, and being a terrestrial planet, it's easier to associate those problems. Even with Titan, it's easier to associate and compare with Earth and solve those problems. Otherwise, Pluto, yeah.
And can I ask a follow-up question?
Yeah, go ahead.
You said that depends on the kind of question you would be trying to answer. And I'm curious, how do you choose questions in the work?
That is easy. Basically, the funding agency decides the question that I get. So for example, with Mars, there is, so at the end of the day, most of this money is public money, right? So whatever research that we do, it has to sort of come back and tell the public, well, we spent your money this way, right? So a lot of these Mars missions are actually biologically driven, in the sense that we want to go and find out conditions for habitability, or we want to go out and find life on another planet, right? So that's the reason why they keep on, or not keep on, why they keep getting funded. And that's the reason why there is a lot of interest in icy satellites as well, right? Satellites of Jupiter and Jupiter and Saturn. So it depends, again, because I am a geologist and I would like to answer questions around habitability, and I can't really find a better analog than Mars in the solar system, so I'd go to Mars.
Most of these questions are sort of, they're not questions that we had asked, but they're the questions that have been around for a long, long time. Sort of, are we alone in the universe? How did the universe start? Could other planets be habitable? What happens as you go sort of out of the solar system? They're sort of the really big questions. So you've got to ask what the smaller questions are to chip away at it. So are we alone in the universe? The easiest way to answer that would be go to Mars and look for evidence of life. But the chances are is that the evidence of life will be sort of in rocks that are 3 billion years old. So then then you have the question of geology, and you need the geologists to sort of go and look at those rocks to investigate whether there's any evidence of life in there. Well, the geologists and then the geochemists to sort of look for that evidence of life. So it's sort of a roundabout way of answering those really old questions.
Any more audience questions? Anyone feeling brave again? Go ahead. Oh, down here. I thought you'd seen someone at the back there.
You mentioned the chlorates in the do we know where that's come from and what's caused that?
I don't know off the top of my head. There might be some ideas. It could be a mixture of sort of salts in the soil, which have then been oxidized by cosmic bombardment. So there's lots of UV rays and cosmic radiation coming in, because Mars's atmosphere is so thin, it can just get straight down to the surface. Earth's atmosphere is about the equivalent of having a 22 meter thick block of concrete above your head. That's sort of the filtering effect of Earth's atmosphere. But because stuff can get through Mars's atmosphere relatively easily and to the surface, it can penetrate into the surface about 2 meters-ish. So all these high energy interactions from the UV rays can sort of break up carbon dioxide, which then can, you'll have oxygen radicals, which can combine with the chlorine molecules to make these perchlorates.
Quite detailed answer. It's getting a bit late for that intense science. I have a question here from online. Someone's asking, could solar power work on Mars even though it's further from the sun?
Yeah, it does work. I mean, with all the previous rovers, I think before MSL, all the rovers were solar powered.
Yeah.
And since MSL, they have started using the RTGs, I guess.
Yeah.
With the rovers. The only drawback why they moved to using more nuclear fuel instead of using solar power was basically it can work day and night. You don't have to worry about cleaning off the solar panels again, and again.
And they work in dust storms as well, so you can continue doing science all through the winter and through dust storms, and you just get a lot more power from a 4 kilogram lump of plutonium. I think the solar panels on ExoMars were making
the
about
Rosalind Franklin mission would have
about 50 watts of power maybe, but when Curiosity landed on the surface, the RTG was making about 120 watts of power. So you could do twice as much. And the added bonus of having a RTG is that you don't waste half of your power for survival heating. Because the lump of plutonium's hot, you can just have radiators surrounding it and take some of that heat around the body of the rover for heating your electronics and actuators and joints. So then all of the electric that the RTG makes, you can use for doing science or moving the rover around. Whereas if you had solar panels, half of that power goes just for heating things. So you only end up with 25 watts of power to drive the rover and do science and communicate and things like that.
At least there's some preliminary evidence that the solar powered rover actually lasted quite long. So it would probably, and I don't think any of the nuclear powered would probably last that long.
Yeah, so
fuels.
Yeah, so Curiosity is probably going to last another 3 to 4 years. But as time progresses, it goes from being able to work five or 6 days a week. At the moment, it only works about 4 days a week. It has Thursday off to recharge the battery, just because the RTG is making less power. And as you sort of go along, sort of that power sort of decreases. Opportunity was able to last for 15 years because occasionally there'd be a wind storm event that would clear the solar panels. And once you cleared the solar panels, then you went back up to sort of like nearly new power levels. But it was the global dust storm in, was it 2018, that eventually got it. And it was a pretty bad one. From the pictures Curiosity took, normally you can see the crater rim, which is about 30 kilometers away. But over the course of a few weeks to a month, you can sort of see features in the distance sort of gradually sort of receding into the dust until you could maybe only see maybe 50 or a few hundred meters distance from the rover. The rover was still able to work though and do science because we could still see features 50 meters away or further, but you just couldn't see that far. But it would have had a massive impact on the rover if it was solar powered.
Okay. Take another question over here, Jenny.
I was wondering, how likely would it be that the astronauts would be able to completely override so that NASA would have no control over the ship like they did at the end?
I don't know. Depends how good at programming they are.
Yeah, if they can hack into the system, probably.
Okay, thank you.
Maybe there probably would be some sort of override in case there was an emergency, but they wouldn't take that decision lightly.
Yeah, I think there would be very set protocols for each eventuality how you function, and I don't think many people like to drift off that route.
Okay, I think we've got time for a couple more questions before we wrap up. But anybody's got any burning questions left? Over here.
I just wondered about the sort of scale of the planetary features, I guess, geological features, like how big are some of the craters, and similarly with the mountain ranges, are they bigger than they would be on Earth if they were formed under a similar process, or is that to do with gravity or atmospheric pressure, or are they similar, or
some features are similar sorts of size. So dunes are sort of a similar sort of size. Forgetting about the large ripples, the craters can be anywhere from about sort of yay big. In Gale Crater, Curiosity's constantly driving past small craters, and they have found about 60 meteorites, or maybe not 60 meteorites, but they found tens of meteorites on the surface just lying there. The larger craters are sort of over 150 meters or 150 kilometers. So Gale Crater is 150 kilometers in size. Mountains, so volcanoes.
That would be Olympus Mons is sort of the biggest in the solar system.
Yeah.
You don't have particularly mountain ranges as you would see it on Earth, primarily because of plate tectonics. We have plate tectonics. We don't think that there was ever plate tectonics on Mars. Ocean is debatable if there is, and if there was ever a northern ocean. I think there is some atmospheric evidence in terms of deuterium, or the heavier isotope of hydrogen, being more, about I think 8 times more than on Earth, as evidence that there might have been ocean. But apart from that, there haven't been consistent evidences for ocean. And even in that case, that ocean is also considered to have been formed from an impact and not from plate tectonics, as is the case on Earth. So it's basically on the scale. So on the micro scale, in terms of sedimentary features or features formed by water or by air, there is close association to what we could see on Earth. But on larger features, your so in case of Olympus Mons, if that is also kind of an evidence, because we think that might happen, that might be due to a hotspot, right? So you have hotspots here on Earth, for example, in Hawaii, right? So Hawaii Islands are basically hotspots. So if the plate would move, you would have a new location where the new volcano would form. We wouldn't have that. So sort of, yeah.
Olympus Mons is 28 kilometers high and about as wide as Poland. It covers about the same sort of area as Poland. And it's a relatively new feature as well. It apparently formed within sort of the last billion or so years.
Okay. Anyone gonna take the plunge? One more question. I think that's quite a nice one to end on, though, with like massive volcano on the face. So, okay, thank you so much for joining us this evening, and thanks as well to Stephen Kartik. If your interest in space has been piqued, or it was already there, we do have a whole lecture series on YouTube from last year, which was the Society's 2021 Year of Space. So check those out for a whole lecture series on the geology of the solar system. We also have an exhibition, Spacegate, which was originally out in the courtyard of the Royal Academy, but is moving to Harwell Science Campus in Oxfordshire. So if you are passing there, do check it out because it's great. But for the rest of it, I'm going to say enjoy the rest of your evening. Thanks so much for coming down, and we'll see you again. Thanks, everyone. Some like outro music.
I forgot to tell them their homework is to go and have a look at the Pathfinder landing site.